Hello everyone, welcome to our Node.js series. In this series, we will learn Node.js from the very beginning and gradually build our backend skills. Let's begin with the first topic, Introduction to Node.js. Before Node.js was created, JavaScript was used only inside the web browsers. It was mainly responsible for adding interactivity to web pages. Whenever developers wanted to build the backend of an application, they had to learn another programming language such as Java, Python, etc. This means using one language for the front end and another for the back end, making development more complex. Randall noticed this limitation and asked a simple question. If JavaScript is already easy and powerful for building the front end, why can't we use the same language to build the back end? This led to create Node.js in 2009. So what is Node.js? Node.js is a JavaScript runtime environment that allows us to run JavaScript code outside the browser. When we say outside the browser, we mean JavaScript is no longer limited to Chrome, Firefox, or Edge. With Node.js, JavaScript can run directly on our computer. So far, we have learned what Node.js is. To really know why companies use Node.js, we need to understand its features. So let's discuss them one by one. Fast performance. Node.js is built on Google's weird JavaScript engine, which converts JavaScript code into machine code for fast execution. Asynchronous and non-blocking I/O. Node.js doesn't wait for one operation to finish before starting another, making applications much more efficient. We'll discuss more about asynchronous and non-blocking I/O in our following videos. Event-driven architecture. Think about a doorbell. When someone presses it, an event occurs and the person inside responds. Similarly, Node.js performs actions when a specific event occurs on the client side. Single-threaded. Node.js uses one main thread along with event loop to manage multiple operations efficiently. Imagine one manager coordinating with many workers efficiently instead of doing every task alone. Highly scalable. Node.js can efficiently handle thousands of users at the same time, making it suitable for modern web applications. Node.js can run on Windows, Linux, and macOS, so developers can build applications regardless of their operating systems. After understanding what Node.js is, the next question is, where is Node.js actually used? Node.js is widely used because it can efficiently handle many users simultaneously. In the chat applications, when you send a message, it reaches the other person almost instantly. Node.js is excellent for building these real-time communication systems. Streaming applications. Let's take YouTube or Netflix as an example. When you watch a video, you don't have to wait for the entire video to download before it starts playing. Instead, the video begins playing immediately while the remaining part continues to load in the background. This process is called streaming, and Node.js is highly efficient at handling streaming applications because it can process data continuously as it becomes available. REST APIs. Whenever a website or mobile application needs data from the server, it communicates with the backend using APIs, application programming interfaces. Node.js is one of the most popular technologies for building these APIs because it is fast, efficient, and can handle a large number of client requests simultaneously. For each and every concept, there are pros and cons. So, the advantages of Node.js are 1. The performance. It is very high. Number 2. It is highly scalable. Number 3. We are using one language for both front-end and back-end. Number 4. It is excellent for I/O operations. Means the operations may be read files, communicate with database, or send network requests, etc. And the disadvantages of Node.js are it is not suitable for CPU intensive tasks. It is a single threaded in nature and the callback complexity. Earlier, developers relied heavily on callbacks, which often resulted in deeply nested code called callback hell. Today, this problem is largely solved using promises and async and await. Now we have a basic understanding of what Node.js is and why it has become one of the most popular technologies for backend development. In the next video, we will learn about Google's V8 engine and understand how Node.js executes JavaScript outside the browser. Thank you for watching. Hello everyone, welcome back to the Node.js series. In our previous video, we learned what Node.js is. Now, let's understand something more interesting. If JavaScript was originally designed to run inside a browser, then how does Node.js executes JavaScript outside the browser? To understand that, we need to understand two things. First, what the V8 engine actually is, and second, the complete picture of how Node.js works behind the scenes. So let's start with the basics. Every computer's processor only understands one language, that is machine code. It doesn't understand JavaScript, Python, or any other programming language directly. So, when you write a program in any programming language, something needs to translate that code into machine code so that the computer can actually understand. That's exactly what V8 engine does. V8 is simply a JavaScript engine developed by Google. In simple terms, it is a program whose only job is to take your JavaScript code and execute it by converting it into machine code. V8 was originally built for Google's Chrome so that the browser could run JavaScript on web pages. But V8 itself has no dependency on the browser. It is just a JavaScript execution engine. Here is an important catch. Since V8 doesn't depend on the browser, it can be taken out of Chrome and placed anywhere else that needs to run JavaScript. And that's exactly what Node.js does. Node.js embeds V8 inside itself and uses it as the engine that executes JavaScript. So when you run a JavaScript file using Node.js, it is a V8 engine working behind the scenes to actually execute your code. When you run a JavaScript file using Node.js, V8 starts executing your code. That part we already know. But the moment your code asks for something like reading a file, making a network call, or setting a timer, V8 steps back because that's not its job. libuv is the component that handles all these background operations for Node.js. Whenever there is a task such as reading from a file or writing on a network response, Node.js hands the task over to libuv. libuv takes care of it in the background, completely separate from the V8. And this is the important part. While libuv is busy handling the task, V8 doesn't wait. It simply continues running the rest of your JavaScript code. Nothing gets blocked. Once libuv finishes the task, say the file has been read, it brings the result back, and Node.js runs your corresponding function with that result. So overall, the working of Node.js can be understood as a partnership between two components. V8 that executes the JavaScript code, libuv it handles the background time-taking operations. This partnership is exactly why Node.js is so efficient. Your program never sits idle, waiting for slow operations. V8 keeps running your code, while libuv quietly works in the background. So finally, let's look into three things from this video. First, V8 is Google's JavaScript engine. Its only job is to execute JavaScript. Second, V8 cannot handle things like files, networks, or timers on its own. Third, because of the teamwork between V8 and libuv, Node.js can run your code very efficiently. So in this video, we understood how Node.js works internally. In our next video, we are going to learn the complete architecture of Node.js. Thank you for watching. Hello guys, welcome to our Node.js series. Before we jump into the complete Node.js architecture, there are a few important JavaScript concepts that we need to understand first. So in this video, we are going to understand two very important concepts, synchronous and asynchronous execution. So let's start with the real life situation. Assume we need to do three tasks: writing record, having some coffee, watching a movie. What would you do? In general, you would finish the record writing, then move to have some coffee, and then watch a movie. That's basically the idea behind synchronous execution. So we can simply remember synchronous execution as finish one task, then move to the next task. Now let's see the same idea in JavaScript code. Here we have three lines of code which is used to print output, same as how we use print in Python. When you execute it, it prints start the program, then task 1 and then end of the program. Here the statements are simply being executed one after another. So now let's run this in the system and check. Here you can see I have written the same thing in a file named synchronous.js. And since we know that Node.js is written in the JavaScript programming language and compiled by V8 engine, we can simply run it by typing the name node followed by space and the name of the file, that is synchronous.js. Now press enter. If you look carefully, the output is start the program, then task 1, and next end of the program. So based on the output, we can observe that it is synchronous execution. Now think of a situation. What happens if one of our tasks takes some time to complete? For example, imagine we are waiting for something to happen. Do we really want our entire program to just sit there and wait? This is where asynchronous execution becomes important. Now assume a real life situation. You happen to be in a restaurant and you ordered 10 biryanis as takeouts or parcel. And the food might take some time to get ready, right? While the food is getting ready, you won't just wait idle, right? You can talk to a friend, check your phone, or do something else. Once the food is ready, you can deal with it. That's the basic idea behind asynchronous behavior. Instead of simply waiting, other works can continue. Now, let's bring this idea into Node.js. Here, I started by printing start the program. Then we have a set timeout. Here, we are asking JavaScript to run this function after 2000 milliseconds, that is 2 seconds. Now, here is the important part. While we are waiting for those 2 seconds, will JavaScript simply stop executing the remaining program? Let's find out by running it. If you look at the output, in the first line it is showing start the program, then end of the program, and only after that we got task 1, that too after 2 seconds. But wait, we didn't write task 1 before end of the program in our code, right? So why didn't task 1 print first? Because the set timeout operation is asynchronous. JavaScript doesn't simply wait there for 2 seconds before continuing the next statement. It allows the rest of the code to continue. Now, before we move on, let's try something interesting. What if I change these 2 seconds to 0 seconds? You might expect the output to change, because we are not really waiting for any noticeable amount of time. But remember, set timeout is still being used asynchronously. So let's run it and look at the output. We still got start the program, end of the program, and then task 1. This tells us something very important. Even if the asynchronous operation takes almost zero time, its callback will execute only after the currently executing synchronous code has completed. So now we can understand the difference. In synchronous, we wait for the current task to finish before moving forward. In asynchronous execution, a task can take some time, but other code can continue executing instead of simply waiting. That's the basic difference. Now we have an interesting question. If JavaScript is executing our code one statement at a time, then how was it able to handle this asynchronous operation? How did JavaScript know that it should execute task 1 later? And who decides when that function should actually run? This is where the real story begins. To answer these questions, we need to understand two very important concepts: the call stack and the event loop. These are the concepts that will help us understand what is actually happening behind the scenes. So in our next video, we will discuss about the call stack and event loop. Thank you for watching. See you in the next video. Hello guys, welcome back to our Nodejs series. In our previous video, we learned about synchronous and asynchronous execution. And at the end of that video, we were left with a few important questions. If JavaScript executes our code one statement at a time, how is it able to handle asynchronous operations? How does JavaScript know what it needs to execute right now? And what happens when an asynchronous operation becomes ready? To answer that, we need to understand two very important concepts: the call stack and the event loop. Let's start with the call stack. The call stack is the mechanism JavaScript uses to keep track of the functions that are currently being executed. Whenever JavaScript starts executing a function, that function is added to the call stack, and once that function finishes execution, it is removed from the call stack. The call stack follows a simple rule called LIFO, last in, first out. Now this might sound a little technical, so let's understand it with an example. Imagine a restaurant with a chef. The chef is preparing a dish of noodles. So the main task now is to prepare the noodles. But before the chef can finish the noodles, there is another task that needs to be handled first. The water needs to be boiled. So the chef temporarily sets the noodles aside and starts boiling the water. Now boiling the water becomes the task the chef is actively working on. Once the water is boiled, the task will be completed and the chef goes back to the earlier task, preparing the noodles. This is very similar to what happens inside the call stack. When we call a function that prepares noodles and inside it we call another function to boil water, JavaScript first starts executing the noodles function, so it enters the call stack. Then since that function calls the water boiling function, that one gets placed right on top of it on the stack and becomes the current execution. JavaScript executes the boil water function first. Once it finishes, it is removed from the stack. Then JavaScript goes back to the noodles function and continues from where it left off. Finally, once that also finishes, it is removed and the call stack becomes empty. So that's the basic idea behind the call stack. When the function starts executing, it is added to the stack. When it finishes, it is removed. And when function calls another, the new one is placed right on top of the current one. That's why we call it a stack. So far we have seen how the call stack handle normal function execution. But remember, JavaScript can also perform asynchronous operations. So let's bring an asynchronous operation into the picture and see what happens. Let's take the same example we used in the previous video. When JavaScript starts executing, the first statement logging is an asynchronous operation. It enters the call stack, executes, and prints start the program, and leaves the call stack. Next, JavaScript reaches the timer operation. Now, something different happens. This is an asynchronous operation. JavaScript doesn't keep the call stack occupied for those 2 seconds. Instead, the timer is handled by the runtime. So the JavaScript moves on to logging that enters the call stack and executes and prints end of the program. At this point, the call stack becomes empty. But what happens to the asynchronous operation we were started earlier? After those 2 seconds, the timer completes and that work is now ready to be processed. But it can't simply jump into the call stack whenever it wants. Something needs to check whether the call stack is available and decide when that work can be processed. And that's exactly where the event loop comes in. Now imagine we have a restaurant manager. The manager keeps checking the chef's working area and asking, is the chef free? If the chef is busy, the manager waits. Once the chef becomes free and the earlier work is ready, the manager brings that work to the chef. This manager represents the event loop. Now let's see exactly what the event loop is doing in our JavaScript example. We already know start the program gets printed first. Then we reach the timer operation. It is handed off to the runtime. So JavaScript doesn't wait there. It continues on to log end of the program. So end of the program gets printed. At this point, the synchronous part of our code is done and the call stack becomes empty. Now, after 2 seconds, the timer finishes. That asynchronous operation is ready to be processed. But remember, the call stack is the only place where JavaScript code actually executes. So, this completed work can't just execute on its own. It has to wait until the call stack is available. And this is where the event loop continuously checks the situation. It keeps asking, is the call stack empty? If the answer is no, it waits. If the answer is yes, and there is work ready to be processed, it coordinates that work so it can enter the call stack. Only then does the associate code actually execute. Now, what if the call stack is busy? Let's consider one more situation. What if an asynchronous operation becomes ready, but the call stack is still busy? Imagine the manager. He has an order that's ready, but the chef is currently in the middle of preparing another complicated dish. Can the manager interrupt the chef and force them to immediately handle the new order? No, the chef is already busy, so the manager has to wait. The same thing happens in JavaScript. If the call stack is busy executing code, the event loop cannot interrupt that execution. The ready asynchronous work simply has to wait. Only once the call stack becomes available can that work be processed. So remember, the call stack keeps track of the functions that are currently being executed, and the event loop coordinates the flow of ready asynchronous work. This distinction is really important. So in this video, we learned about two very important concepts, the call stack and the event loop. In our next video, we'll discuss the complete Nodejs architecture. Thank you for watching and see you in the next video. Hello guys, welcome back to our Node.js series. In our previous videos, we already discussed the working of V8, libuv, call stack and event loop. In this video, we are going to discuss the complete architecture of Node.js from start to end. Now, imagine you are on a shopping website like Amazon or Flipkart. You saw a pair of headphones which are so good and you click add to cart to buy later. The moment you click the button add to cart, your phone sends a small request to the server. The server is a computer that runs the website. The moment your click reaches the server, V8 starts running that code. While it is running, this code sits in something called the call stack. Think of the call stack as V8's hands. It can hold only one piece of work at a time that is currently executing now. To actually add the headphones to your cart, the server needs to write that down somewhere permanent. That place is called database. This is like a big record book the server keeps. Writing to this record book takes a bit of time since it is an asynchronous operation. It is not instant, like adding two numbers. It involves reaching the specific database, writing, and waiting for confirmation. If we had just sat there holding this task and waiting for the database to reply, its hands would be stuck. And while it is stuck, it can't help anyone else in the website either. So instead, Wait hands this task to libuv. Libuv is built exactly for this. It handles the specific operations like storing the headphones in the add to cart list in the database. The moment Wait hands it off, its hands are free again immediately. Here is the important part now. While libuv is quietly working on your cart update in the background, V8 isn't just waiting around either. It goes and picks up someone else's request, maybe another visitor searching for shoes. This is exactly why one Node.js server can serve thousands of people at once. So now remember, we are adding the headphones into the database. So after successfully storing, it has to send some response like got successfully update back, right? So the V8 has to handle this response again. But call stack might be busy with some else task at the exact moment. So who will check call stack and the background operation? Both are finished. This is where the event loop comes in. Its entire job is to keep checking over and over. Has libuv finished anything? Is V8 free right now? The moment both are true, it has the finished result over to V8. Now V8 takes this result, finishes the small remaining work like putting together a reply that says add it successfully and sends it back to your phone. So in your screen, you can see add it successfully. All of that happens in a fraction of a second. Let's quickly recap what happened. The moment you click add to cart, the request reaches the Node.js server. Then V8 starts executing the JavaScript and that execution happens on the call stack. And if the application need to perform an asynchronous operation, it will be handled by libuv. During this time, the call stack will become free to handle other JavaScript work instead of waiting. Once the JavaScript asynchronous operation finishes, the result becomes ready. The event loop coordinates the completed work and brings it back to the JavaScript side when the call stack was available. V8 then executes the callback and finishes the remaining JavaScript work. Finally, the response was sent back. In our next following videos, we will discuss the global objects in Node.js. So make sure you don't miss that one. Thank you for watching.